Hi everyone. So, are you excited about this IdentityShield Summit, which is going right now? Yeah. So the first time we are organizing this, and I am really glad to be part of that. And the opportunity I am getting to speak here and sharing my knowledge to the other people, that's great opportunity to me. And I guess this is the great platform to convey or exchange the information as well. So today my topic is about the VPN. We all know that VPN we use and it's secure, but is it really secure? That we are going to check. So does anyone know what exactly is the VPN? Like, why do we use VPN? Right. So there to connect to internet as well we use in the organization level. So let's move forward. Let's see how exactly this particular Localnet attack, which I am talking about, using manipulating the routing tables, works, and how it's vulnerable. So let me introduce myself again first. It's Dhruv Bhavsar, who is working 4+ year in the miniOrange and expertise in the cloud and the workspace security. And so let's move forward. So why does generally people use the VPN? So सबके माइंड में पहला कंसेप्ट आता है to watch movies. To watch movies and which the movies which are not available in their region, they generally connect to the VPN and watch those movies and etc. But when we connect to the VPN, it's too much slow. It takes too much time to stream the particular video and it takes a lot of time. But in the concept of the organization level, there is no as such use of the VPN to watch movies. Obviously, these are to access the resource and other things. So we will check that out, why exactly we should use the VPN, how it works. But before that, what if there is no VPN? So in the traditional way, how it works is, for example, you have a client. So the client directly connects to your Wi-Fi. You all use the mobile phone and the laptop devices, right? So you directly go to mobile and phone and connect to your Wi-Fi. And that Wi-Fi has their own ISP provider. And that ISP provider then serve the request and give the resources, right? So this is the traditional infrastructure which generally everyone follows, I guess, in right now. But what if those Wi-Fis and the ISP is malicious? Can you identify that? We cannot identify by looking that. Even at here in the this particular conference, any Wi-Fi can be malicious and your data can be leaked. So there is no as such way to identify the malicious Wi-Fi and the ISP networks. That's why generally the attacks happen. The attacker can create malicious Wi-Fi and you can connect that Wi-Fi. So the simple example for that is, let's say if you are going to Starbucks, right? Everyone goes there. And on the Starbucks, everyone loves to drink a coffee with their laptop, MacBook खोलेंगे, show off करेंगे थोड़ा, and then work करेंगे अपना, right? So in that, they generally tries to connect with the Starbucks free Wi-Fi only. And that is free, so any attacker can similarly create one copy of that and track your activity. So we are going to see how it works, how they can track it out, and over the VPN how it works. We will check that out. But there is one question. Right now we all use the HTTPS secure layer. Then do you think still we are not secure? So yeah, even if we use HTTPS, that is the secure layer, but there are certain attacks which is like SSL strip. Using those, the attacker can manipulate this website works for HTTP only. That doesn't have HTTPS secure protocol. And in this way, attacker can manipulate you, the client which is going to connect with that malicious Wi-Fi can easily connect, okay, yeah, this is the HTTP and I just need to log in here only, and your details are going to be leaked. So this is the case also when the malicious Wi-Fi you're connecting, your IP addresses, your domain which you're trying to access, those information can be easily leaked. like the attacker can easily traverse and see those details. So for those some reasons, I guess to use the VPN is good approach, because the HTTPS is secure but not that much that attacker cannot manipulate. So as I mentioned, generally we use the VPN to protect the route, protect the traffic, which in your organization, which you access any resources within your organization or not. So basically every traffic, when you connect to the client with the VPN client, with the VPN server, all the traffic which are there goes via the VPN. So the VPN makes sure that your traffic is secure and goes via the encrypted tunnel, which the client created that. So that is the one point, which is the defend against the malicious Wi-Fi and the ISP networks. We use VPN, and that where we should use as well. In this research, we will see even if we use the VPN, that is not that much secure, because one of the vulnerability which I am going to talk about was found out, and in that your traffic can be leaked. So that means your traffic cannot goes via the VPN. That traffic directly go to the main server without even interacting with the VPN. So let's see how it works. So we need to understand first what is the exactly IP route table, because to understand that how network goals work, we need to see first how IP route table works. So the IP routing table is basically, it's a set of table, and it indicates that your data is going through this particular table or this particular tunnel. So in the system, in the laptop, by default, there are certain tunnels. For example, there is one Ethernet cable, there is one Wi-Fi cable, WellNet connection. If you connect with the VPN, then there is a VPN tunnel. So we just need to make sure in which tunnel our traffic is going, or our data packets are going. We need to ensure of that. So in the Linux system, if you go over the terminal and type IP space route, so this will show this kind of particular output. So what it means by default? So it says the default via tunnel 0. That means the default traffic of all the particular client or the Linux system will go via tunnel 0. And tunnel 0 here is the VPN tunnel. So we are assuming here that our system is connected to the VPN, and it has already established the connection and all the secure thing which the VPN does. After this, when we type this particular command, the default all traffic will go via tunnel 0. That is the socket layer. Now, there is one more case, which is the exception we are talking about today, which is the Localnet exception. So what it does is, when we establish the VPN connection ho gaya, but the local network, which lies on 192.168.1.0. So that is your local network basically. That local networks goes via Ethernet cable. So that means if any traffic which we are accessing or any website which lies into the local network, uska traffic pura Ethernet 0 se jayega. That doesn't go with VPN tunnel. That means hamara leak ho gaya. Our data packets are leaked now. And in the VPN process, the one more process done is setting up a secure DNS server. So that particular VPN generally does. And at that level also, sometimes the DNS spoofing the malicious attacker can do. They can set up their own malicious DNS entries in your system. Because of that also, sometimes the traffic is routing without even going to the your particular servers. So let's see how exactly it works. So we have client, we have one VPN, and we have one target site. So the threat model here is the same, that the attacker needs to be within the range of your periphery. So let's take the same case. I'm going to the Starbucks, and I'm just having my coffee and working in my laptop, and I have connected to the VPN. But the attacker is also sitting in the Starbucks. he has created one malicious network, and by mistake, or I was not exactly sure, because by looking at the Wi-Fi network, I am not able to understand that this is the malicious or this is the actual genuine Wi-Fi network. So I have connected to the malicious network. So that malicious network attacker have created, and by mistake I have connected to that particular Wi-Fi. So in that, what he has done is, he says, yeah, your local network IP is 1.2.3.0. So that will be your local IP. So that means here configured in my local system, and all the traffic of this particular, whatever lies in this local network, the target.com right now lies in the local network because it is 1.2.3.4. So that is basically 0.0 to 255. That is the range of the IP which lies into the local network, and there's a subnet /24, so that can be increased by based on the device to device. So whenever someone connects, the Wi-Fi, malicious Wi-Fi, sends the response that this is my local network. Then okay, my Wi-Fi is connected. Now I'm going to work, and I know that if I connect to the VPN, my traffic or my everything which will goes via the traffic, it will be secure. That's my assumption. So I have connected, created a tunnel of 2.2.2.2, which is the VPN tunnel here. Okay. So what it does is it sets up a secure DNS server, the VPN process. It's a VPN process part, and it's now connected here. So once it's connected, the default routing table, when we go to the IP routes, the same IP route will be there, because the default via the tunnel 0, and the second thing is the local network access, which goes via the Ethernet 0. So I guess till this everything is clear. Now, if I visit the random site, which works on any IP addresses, let's say 1.2.4.5, which doesn't lies on the local network, that particular site will go via the VPN, and VPN, it will serve all the data packets. So that data packets are secured now. But for the second thing, which I try to access if the target.com, in that case, everything goes via 1.2.3.4. That means that particular thing lies on the local network, and yeah, the malicious network can easily manipulate the request now. Okay, so it can intercept your traffic, it can leak your traffic, it can manipulate, it can block your request, it can do everything, because once everything goes via your traffic, you have all capabilities over there. So this particular scenario was try to configure or try to do on the multiple OS with the multiple VPN client applications, and the founding was that iOS was the most vulnerable VPN client, and their infrastructure was not that up to mark, because of which the leaking of the data packets were there. So if you connect your iPhone with any malicious network and connects to the VPN, and you thought that, yeah, I am secure now, no, there can be a leakage. And the reason for the Android, for the most green part, is because Android provides a stable API interface. So whenever you need to configure any API, like any VPN client or any VPN client is there, they just need to make an API configuration. They need to do an API call. Their configuration is done, and that API handles, the OS part is handling the part of configuring the VPN, not the application. So in that case, the OS capabilities were there, and because of that, and there was some more reason which we'll discuss, the special cases why this particular green line is there in Android and not in the iOS. We will see that. So let's check a quick demo for that, like how it works, how we have created one malicious Wi-Fi network, and how after even connecting the VPN, it goes via the malicious network only. And using the tools like Wireshark and these kind of tools, we can easily track the details as well. So in this particular portion, we are creating a test VPN network. In this particular, we have created test network over there, and in the test network, there is a password and everything. We have done that. The VPN local, what we are doing is we are keeping this nyu.edu site here, which is going to be whitelisted for the VPN local network traffic. So this is, we have just created our own malicious Wi-Fi network. Now, when I go to my Mac OS or try to connect with the test network and open my VPN and application and connect to the VPN. Now I'm connected and try to access any other site. So it will say, yo, it works. The networking is working. And when I go to the nyu.edu and tries to enter the credentials over there, but this doesn't go via the VPN. So whenever I submitted the request here, when I go to my Wireshark software tool, in that I can see my username and password over there. That means my data is leaking. So anyone can steal your even Facebook credential, Google credential, if they manipulate you like, no, this site works only for the HTTP. You can enter your credential here. But after that, everything is gone. So this was the actual demo which was implemented and saw that, yeah, the data packets can be lost even after connecting to the VPN. But I mentioned some of the special cases are there in which the VPN was not working, like the particular attack was not working and it was preventing the attacker to leak the information. So what was those cases? So the first case was, so many of the VPN client in Android application and the Mac OS, what they were doing is whenever someone connects to the VPN, they directly blocks the local network access. So if they block the local network access, that means you cannot access anything which lies in your local network. Give me a simple example. Everyone has printer in their office, right? Which works on their local network only. So generally if you want to connect with the printer, we directly connect. हम वहाँ पे नहीं करते कि हम वाईफाई से कनेक्ट होके हम वहाँ पे कनेक्ट करेंगे, नहीं. We directly connects जो भी हमारा printer है and directly prints everything. So this is helpful whenever we connect to the VPN, and even if after connecting VPN we can access the printer and everything. We don't want to switch the network. But those applications which shows in the particular green bar blocks that access too. So you cannot even access the printer. If you want to access any local site or any local IP address, you need to turn off your VPN, then only you can access it. And if you want to access your office things or maybe organization resources, you need to connect with the VPN and then you can access it. So that's how they make it secure. And the vulnerability was not there in those particular applications. The second case was about VPN Proxy Master, that is generally available on iOS devices and other OSs. So what it does is basically it creates a kind of proxy environment. So what proxy is basically like transferring your data to one server, and the server will send the data to your resources or the main backend server. So the similar way it does that in the returns it gives, so we saw that in the VPN it was returning the local IP network, right? That 1.2.3.40. So that is changed to a special IP, which IP only has the VPN Proxy Master application. And that is configured in our client system. That means all the traffic of that particular application goes via the special IP, which Wi-Fi, the VPN have configured. Now, whenever we send the request, the VPN sends to the original IP address. We cannot send it directly. So that's how they have make it secure. And they just forwards the request to all the real IPs and giving their special IPs to the client. So this was one of the way they have already prevent this particular vulnerability. The second case which we saw about the iOS, why iOS was most vulnerable. Generally हमको लगता है कि iOS is most secure phone. सब उसी की तरफ जाते हैं. But iOS also has the vulnerability. So not the iOS only, the application which was developed in the iOS platform was also vulnerable because the iOS provides two options there. The first one is include all network, which means whenever you create an application, you need to define like what kind of network access that particular application has. So in that, generally everyone does true, but they forgot to do the other option, which is exclude the local network. The vendors they developed the application, the VPN client application, they did not include this particular option. Because of that, the most of the application was vulnerable. And even in the iOS about the 14.2, this option came, and most of the vendor started to including this particular exclude option and created their upgrades. After that, this particular vulnerability was not there. So this was the iOS case in which how the the vendors were not able to even now many applications vendors were not enabling, has not enabled that. So from the takeaway here, the first thing, if you are building any VPN client application or any source of VPN, something like that, so first thing I guess we should make sure how exactly your traffic is going through. Is your traffic is going via the VPN or not? Any kind of traffic. If there is a local network traffic, either you can block it or you can use the approach which VPN proxy master does, which was around sending the traffic to their VPN server and then from there the original server. The second thing, I guess the OS should also provide the capabilities to configure the VPN client securely, similar to the Android, because Android has a very good API infrastructure for that, which I guess the iOS didn't have earlier, but in the latest release, I guess they also provides this kind of option. Because of that, it was secure. So yeah, I guess that's it from my end. So this particular paper was submitted by the Matthew Benioff initially, who is the professor in the KU Leuven University. So if you have any question, you can just ask me. Yeah.
Most of the time we use VPN. Still the traffic goes on in locally.
Can you elaborate the case?
Like as when we are trying to use settings on the dark web or any other source. Most of the time traffic based on local distance.
It depends on the So it depends on your configuration as well. So let's say if your DNS is configured, if your DNS, the local host DNS is configured to traffic the route on your local machine only. In that case, even if you connect to the VPN, but your traffic is going via the local network only. Yeah, so it depends in your system. There's a file /etc/host. If you have configured any DNS entry over there, that this particular domain, let's say google.com, should goes into my local network. In that case, even if you connect to the VPN or anything, you have mentioned that this particular route should go there. So there is a level of DNS also, the system always first check for the system level DNS. What is the DNS entry on the system level? The second is check for the global level. In that case, the browser makes the request and everything. So you just need to make sure what exactly your DNS configuration in your system. If there is any system DNS configuration, it will definitely go via the local network only. So by default, every system has the host file that works as a DNS server. For any domain, if you want to point it to a specific IP, you can do using that. So that is a system specific thing. You can go to your host file. If you use Windows, I guess it's in the C directory. I'm not exactly sure about the location. But if you are on the Linux system or the Mac OS, it's /etc/host file, in which you can configure your domains and which IP it should be point. Yeah.
So we used to connect to multiple VPNs because there were more than 10 available ports to connect to. And once we got connected to a certain VPN, then now our applications,
Right.
we changed the VPN to some other VPN. Certain applications behave different.
Okay. So they stopped working or? Okay.
Behavior is changed. So can you?
So there are certain cases, definitely we need to check those application first, like why exactly they are behaving like that. But there, if let's say I take a case that in one particular case, the application is responding fast and everything is loaded. But in other case, some CSS part or some JavaScript part is not working. So there can be one case which is that particular CSS and JS is not loaded yet. That is one part, because whenever we go to the VPN, the traffic is being slowed. So first we need to make sure that particular CSS is being loaded or not. The second thing is there can be one case, for example, your CDNs are in the server of Australia. Okay, you are connected to the US region VPN. Now there might be a case that Australia is blocking the US network traffic. So on those cases, the behavioral changes will be there for the application level. So I guess is this an inbuilt in-house applications or the SaaS applications which you're talking about? So maybe you need to contact your vendors, because generally if that is the case, either they block completely or not. So if the behavioral changes is there, then I guess their application issue is that, not the VPN. Yeah. Yeah.
So as you demonstrated in that demonstration that the domain mentioned is from HTTPS.
Right.
What happens to its existing DNS certificate that is verified by that own domain, by the owner?
Exactly. So I mentioned one SSL strip. So that is very nowadays that is a very rare attack which generally happens. But what that attack does is, so let's say if your site is running on HTTPS TLS network, google.com. Now, if you are connected to my malicious network, okay, I can say, no, google.com nahi chalta HTTPS pe. It will work on HTTP only. So you'll say, okay, I don't have any issue. Like generally, we don't that much care about the HTTPS protocol. But I think we should be care about that, because any attacker can easily manipulate you like this works only on HTTP. So I guess whenever you connect to any website or SaaS application, just make sure there's a secure option over there so that everything goes via the TLS connection. Okay, so there is one feedback. Your feedback is obviously important to us. So if you can just scan it quickly and drop your feedback about the session, that would be great.
Good. It's good.
So if you have any questions after that as well, I'll be there in the exhibition booth endpoint defense. So you can grab me there, and if you have any questions, you can just ask over there as well.